Hi, welcome to Red Bull Racing, Red Bull Technology. My name is Steve Nevy. I'm the Business Development Manager here. It's going to be my pleasure to show you around our factory. This is where we make our carbon fiber parts. Carbon fiber is an amazing material, very, very strong, but very, very lightweight as well, which is important to us. You'll find carbon fiber in the aerospace industry. Helicopters and particularly fighter aircraft are made in carbon fiber. The process is interesting as well. The carbon comes to us as a woven sticky cloth in different grades. Our guys will take the cloth, will cut it to shape, and then we'll lay it into molds, layer upon layer upon layer. Maybe 30 layers, maybe 50 layers. The whole thing then goes into one of our autoclaves, which is basically a pressure oven, where it's cured at a temperature of about 140 degrees C and 7 atmospheric pressures. The effect of that curing cycle is to turn that sticky cloth into that very, very strong and stiff material that we make the racing car from. Once the carbon components have been in the autoclave and the carbon's been cured, they come into here where they're trimmed and parts are bonded together. In fact, you'd be surprised how much of a racing car is actually glued together. This is a fascinating process called stereolithography. These machines are, on one side, a deep vat of liquid epoxy resin. On the other side is a computer. Our designers produce three-dimensional designs, which are then downloaded into this computer. This computer then projects a laser from one side of the machine onto the roof of the machine and down onto the surface of the resin. Where the laser touches the resin, it solidifies it, layer by layer by layer, until eventually we've produced a three-dimensional object inside the liquid. The whole thing rises up out of the resin and gets cured and onto the wind tunnel model. We produce a scale model of the car, which we test for aerodynamics in our wind tunnel. The Concorde aircraft was tested in that tunnel many years ago. But it's our tunnel now, where we test. It's a constant battle between downforce and drag. It's important that we make the car as aerodynamically slippery as we can so that it cuts through the air nice and cleanly with a minimum of drag. But we want the downforce because at some circuits it's important to get us around corners very, very quickly. Different circuits require different types of aerodynamic configurations. The two extremes are in fact Monaco, where there are lots of tight corners where we need downforce to push the car onto the track to increase grip. The other extreme is in fact the Monza circuit, which is lots of straights and big, long, sweeping corners, where we would reduce the amount of downforce to get the car to go faster in a straight line. We produce many components for the wind tunnel model, far more than we do for the car itself, because this is the experimental stage. This is where we're trying lots of different ideas. Those that work make it to full size and actually appear on the race car itself. Now, although much of the car is made in carbon fiber, we still make many components in metal. Lightweight metals like aluminium or titanium or magnesium for areas of the car like gearbox, hydraulics and suspension. One of the reasons we use these lightweight metals is because our objective is always to try to reduce the weight of the car as much as possible for competitive reasons. And for that same reason, we will machine these components into very fine detail.